Hello and welcome to York Observatory's weekly Teletube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time at York U Observatory on YouTube. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alumni Carswell Ops. I'm Maheen, and I'll be one of your hosts this evening along with Dhyan, June, Arfa, and Matt. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. Tonight, we're delving into some of the basics of astronomy. We will take you through a journey across the solar system and what is beyond briefly. Get ready to learn some very interesting facts about our star system and how it is not the only system in the universe. But before we get started, I'd like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. Welcome again, everyone. Before we get started with our main show, I'd like to give you a little update on what you can see this coming week. Tonight, we have Arcturus and Sirius up, great to view right after sunset. In the upcoming days, we have some interesting events happening. The moon will officially reach its third quarter phase at 1:37 a.m. Eastern Time or 5:37 GMT on Friday. Friday, March 25th, which means that it will be half illuminated on its western sunward side. The week of dark, moonless skies that follow this phase are great for observing deep sky targets, so mark your calendars. It will be a beautiful sight for early risers on the morning of Monday, March 28th, when the old crescent moon will be shining below the group of Mars, Venus, and Saturn in the southeastern sky. This will also make a great opportunity for a photo. The moon will be last to rise just before 5:30 a.m. local time. On the morning of March 30th, the very slim crescent of the old moon will sit a palm's width to the lower right or 5.5 degrees to the celestial southwest, which is of Jupiter's bright dot. At mid-northern latitudes, however, the duo will be just above the eastern horizon around 6:30 a.m. local time. It will not be as visible amidst the twilight glow. Watch out for all these beautiful events and don't miss out observing them at the indicated times. Since we have all of our necessary March updates, I will now pass it over to Dhyan to start us off with our journey of the solar system by giving us a brief introduction on what a planet is.
Thank you for that great introduction, Maheen. Today we will be discussing our solar system and the possibilities beyond it. I will start off this interesting discussion with the topic of planets. The word planet originally described wanderers that were only known as moving lights in the sky. Then eventually discoveries led us to create a definition for these wanderers. And so what is that definition? What is a planet? Well, for a seemingly simple question, there is a very complicated answer. We know that our Earth is a planet, but so is Pluto not too long ago. Then discoveries triggered scientific debates that continue to this day, and we arrived upon the most recent definition of a planet in 2006. According to the International Astronomical Union, a planet must meet these three conditions. Firstly, it must orbit a star. In our solar system, that would be the sun. Secondly, it must be big enough to have enough gravity to force it into a spherical shape. And lastly, it must be big enough that its gravity has cleared away any other objects of a similar size near its orbit around its host star. Although this is our current definition of a planet, new discoveries might result in a change in the definition of what a planet is. And in fact, it was through these discoveries and discussions that Pluto was sadly demoted to a dwarf planet. Dwarf planets are very similar to planets, except for one key difference. A dwarf planet has not cleared away the neighborhood around its orbit, whereas a planet has. And so now that we have defined what a planet is, we can talk about the planets in our solar system. There are 8 planets in our solar system, 4 inner rocky planets and 4 outer gas giants. The gas giants are separated from the rocky planets by something called an asteroid belt. In order from the closest to furthest to the sun, first we have Mercury, which is the smallest planet in our solar system. In fact, it's only slightly larger than our very own moon. And so far, we have not found an existence of a moon orbiting Mercury. Next, we have Venus, which, unlike most planets, actually spins in the opposite direction. And it has an extremely thick atmosphere which traps heat very well, making it the hottest planet in our solar system. And which is surprising, as it's not the closest planet to the sun. Third, we have our home planet, Earth. It's the only known place so far inhabited by living beings, and also the only planet in our solar system with liquid water on the surface. Next, we have Mars, which is a dusty and cold desert, also known as a red planet. Although it wasn't always the way it is now, there is evidence that billions of years ago, Mars was much warmer with a thicker atmosphere. Then we have Jupiter, our first gas giant, and also the largest planet in the solar system. In fact, Jupiter is twice as massive as all the other planets in our solar system combined. It also has a big red spot, which is a storm that is centuries old, and this spot is bigger than our Earth itself. The 6th planet from the sun is Saturn, which has a complex system of icy rings surrounding it, and it's the 2nd largest gas giant in the solar system. 7th from the sun, we have Uranus, which rotates at a 90-degree angle from its plane of orbit. And last but not least, we have Neptune, which was actually first theorized through mathematical calculations. Neptune is the furthest planet from the sun. It's extremely dark, cold, and whipped by by supersonic winds. And now that we know all the planets in our solar system, we can delve further into each planet, starting with Mercury. Mercury gets its name from the Roman god of finance and commerce, who's actually the fastest Roman god. And as mentioned earlier, Mercury is the closest planet to the sun. In fact, for a comparison, if we were to look at the sun from Mercury, it would appear 3 times as large as it does on Earth. And the sunlight would be 7 times brighter. Mercury actually has a very egg-shaped orbit, and even though it's the closest planet to the sun, it's not actually the hottest because it has almost no atmosphere to hold in heat and keep the surface warm. Compared to our Earth, Mercury is only about 38% the size of Earth. And so gravity on Mercury is only 38% of what it is on Earth. Being so close to the sun, its orbital period is also much shorter than Earth's, being only about 88 days. The temperature on Mercury can sway very rapidly, ranging from negative 173 degrees Celsius to a scorching 427 degrees Celsius. But I believe the most interesting fact about Mercury is that although we know the planet is small, it's also currently shrinking. Astronomers believe that this is because of the planet's iron core cooling, and therefore decreasing the planet's volume. Next, let's talk about Venus. Venus is the 2nd planet from the sun, and after the sun and the moon, the 3rd brightest object in Earth's sky. Because their size and mass are so close, it's frequently referred to as Earth's sister planet. Venus is also the planet with the closest proximity to Earth. The surface of Venus is obscured by an impenetrable veil of sulfuric acid clouds. Venus is the 2nd largest terrestrial planet and named after the Roman goddess of love and beauty. On a bright, clear day, the planet's apparent magnitude ranges from negative 3.8 to 4.6, making it visible. The only other natural object that is brighter is the moon. The morning star and evening star are terms often used to describe Venus, and this can be traced back to ancient civilizations that thought Venus was actually 2 separate lights in the sky. When Venus's orbit passes over that of Earth, it shifts from visible at sunrise to visible at sunset. The Greeks called them Phosphorus and Hesperus, while the Romans called them Lucifer and Vesper. And next, I'll pass it on to June, who'll discuss the other planets. Take it away, June.
Thank you, Dhyan. Our next planet is the third rock from the sun, Earth. And at an average distance of 149 million kilometers from the sun, it lies in the sun's habitable zone, the distance from the star where liquid water can exist on a planet's surface. And Earth definitely has liquid water on its surface. It covers more than 71% of the planet's surface. And yes, Earth is habitable. Despite the extreme Canadian winters and dry, scorching heat, I'm sure you all are familiar with how long a year on Earth is and very well acquainted with our one moon. But did you know it is on average 380,000 kilometers away from Earth? But that distance pales in comparison to the average 228 million kilometers that Mars is away from our sun. This is one of the many reasons that Mars is a cold, desolate desert planet. Mars' surface is stained a reddish orange color due to the rust or iron oxide throughout its soil. There are many surface features which suggest that Mars once had plenty of water flowing on its surface. But these days, water only flows in salty soil in some craters in the warm season. The rest is frozen, along with carbon dioxide and large polar glaciers. Could life have existed on Mars in its wet past? Possibly. And that life may have survived till today, similar to an extreme organisms on Earth, surviving cold runs to Tim Hortons or the Antarctic ice. We are, of course, avidly searching for hints of past life or present life on Mars, and helping us is a team of Martian robots launched over the course of the past few decades to study Mars on our behalf. Some of the active missions are the Curiosity rover, the Perseverance rover, and the Ingenuity helicopter. Mars may have one more moon than Earth, but those moons, Phobos and Deimos, are akin to captured asteroids compared to the more planet-like moon that we have in our sky. One planet which has a few planet-sized moons is Jupiter. The four so-called Galilean moons are Io, Callisto, Europa, and Ganymede. Io and Europa are similar in size to our own moon, but way more active. Well, Callisto is just smaller than the planet Mercury. And Ganymede, get this, is a whole 26% larger than Mercury by volume. Jupiter also has 80 known moons, but more and more are discovered each year as Jupiter competes with Saturn for who has the most moons. Jupiter is also 778 million kilometers away from the sun on average, giving it a nearly 12-year journey around the sun. But despite having such a long year on Jupiter, a day on Jupiter is only 10 hours. Lucky astronomers may be able to observe an entire Jovian day in a single night of observing. That means you have a better chance of observing Jupiter's Great Red Spot. As seen here, it's a massive red-colored storm, which has existed for at least 300 years on Jupiter, and is one of the countless storms covering its surface. Very similar to its big brother in the gas cloud composure of Saturn, but Saturn dazzles the eye with an immense ring system made out of dust and ice particles, ranging all the way from grains to boulder-sized boulders in size. The remnants of one or more moons who got too close to Saturn were torn apart by its gravity and strung out in these rings in orbit. Saturn currently has 83 formerly discovered moons, setting it currently just ahead of Jupiter at the moment. But Saturn has a very unique planet-sized moon named Titan, which has oceans of liquid methane on its surface and many other unique features that one can spend an entire Teletube talking about. Saturn hangs out at a brisk 1.43 billion kilometers from our sun on average, leaving it with about a 30-year round trip around the sun. Now on to Arfa, who's going to talk about the even more distant Uranus.
Thank you, June. Uranus. Uranus might be the seventh planet from the sun, but it was the first planet to be discovered by the telescope. It was named after the Greek god of the sky. The planet has the third largest radius of 15,759.2 miles. A Uranian day is about 17 hours, and it takes about 84 years to complete its orbit around the sun. The planet has managed to capture quite a few moons. Total of 27 moons, all named after the characters from William Shakespeare and Alexander Pope work. Well, here's one fact about Uranus. Just like the evil twin Venus, Uranus also rotates east to west. But Uranus is still unique since it rotates on its side. So it's more like if you're at Uranus and observing the sun will appear like rolling ball. Well, we aren't done with the fun facts about the planet here. The planet Uranus has rings. Actually, 13 rings, and the inner rings are kind of narrow and dark, but the outer rings are brightly colored. Uranus is a huge planet and is actually an ice giant. The hot, dense material composing this planet are actually the icy materials like water, methane, and ammonia, all above a small rocky core. Uranus's atmosphere, however, is mostly made of molecular hydrogen and atomic helium with a small amount of methane. Neptune, the eighth star, which is at the distance of 2.8 billion miles from Sun, which is 30 times as far from the Sun as Earth. Well, Neptune is the only planet in our solar system that is not visible through naked eye, and mathematics helped us discover it, since the math predicted there should be an eighth planet somewhere out there orbiting the Sun. Neptune is about 4 times wider than Earth, but it still completes the day in 16 hours. However, the year is 165 Earth years. This planet has the strongest winds in the whole solar system. At high altitudes, the wind speeds can exceed 1,100 miles per hour, and that is 1.5 times faster than the speed of sound. Neptune owns 14 moons, which are named after the sea gods and nymphs in Greek mythology. This planet has 5 rings and 4 more ring arcs. Ring arcs, now you may ask, are clumps of dust and debris which are most likely formed because of the gravity of nearby moons. Neptune, similar to Uranus, is also a huge planet and is actually an ice giant. The hot, dense material composing this planet are the icy materials like water, methane, and ammonia, and again, all above a small rocky core. Neptune's atmosphere is made up mostly of molecular hydrogen, atomic helium, and methane. Well, apart from knowing stars as something that twinkles in the night sky, stars, as per the astrophysical definitions, are any object that is sufficiently massive that it can ignite the fusion of elements in its core due to the gravitational pressure inside the object itself. Stars are huge celestial bodies that are made of hydrogen and helium, which result in producing light and heat by using the nuclear forces burning in the deep core of the star, which may harbor and help with the setting up a system, just like our solar system. The smallest star we know is only 10% of the mass of the sun. In future, however, as the universe continues to expand and more stars are formed due to mixing of heavier elements and also the polluting of the interstellar waterways, fusion will be possible in lower mass objects. Many stars produce way more energy than the sun. The energy source for all stars, however, is nuclear fusion. Let me explain the fusion part here. Stars are made up of hydrogen and helium, mainly, and they are packed so densely that the star center pressure initiates the nuclear fusion reaction. This energy generated in the core is pushed outward to balance out the inward pull of gravity. This energy, when reached to the outer layer of the star, makes the star glow brightly, and the energy travels out in space as electromagnetic radiation. Everything that you see around, and even you, were once simple atoms like hydrogen and helium, and then we had stars. All these hydrogen and helium elements were formed into heavier elements. Inside stars, a process takes place called nucleosynthesis. which is basically making of elements. The stars that were formed right after the Big Bang used up the fuel quickly and made a few elements that were heavier than hydrogen and helium. Once those stars turned into supernova and expelled the elements they had produced, they seeded the next generation of stars. Now, there are many different types of stars in the universe, from protostars to red supergiants. They can all be categorized according to their mass, temperature. Now, stars are also classified by their spectra, the elements that they absorb, along with their brightness, which is also known as apparent magnitude. There are 7 main types of stars. In order of decreasing temperature, it is O, B, A, F, G, K, and M. O and B are uncommon, very hot and bright. M stars are more common, cooler, and dim. Well, now over to Matt, who will tell us about our star, Sun.
Well, thank you, Arfa, for letting us know what a star is. And well, as you may know, we happen to be orbiting a star of our own, the sun. And where do we start with the sun? Well, we can start by giving you some random facts about it. Let's start with the fact that the sun is a 4.5 billion year old star that is 150 million kilometers away from us. And still, because its gravity is 28 times the gravity of Earth, it ends up holding the solar system together, in which we all end up revolving around it. And yes, obviously including us. The sun is made up mainly of hydrogen and helium, heated, we could say, thanks to the nuclear fusion in its core. It is considered to be a main sequence star, and its color is, you could see it as yellow, although in reality it is closer to white than yellow. In other words, the sun's color should be considered more of like a mix of all colors instead of yellow. You can see it as yellow. And now when we see the sun, we don't only see its color, but we feel the heat coming from it, even though we're millions of kilometers away from it. And well, it could be due to the fact that the sun happens to have a temperature of around 5,800 Celsius and a whopping 15.7 million Celsius in its core. Not only this gives us some warmer days during this cold winter in Toronto, but also this makes the Earth a suitable place to harbor life. Brighter than at least 85% of the stars in the Milky Way, the sun happens to be 100 times wider than Earth and about 10 times wider than Jupiter, which is the largest planet of our solar system. But nonetheless, our star is just a medium size compared to other stars in the main sequence. Now, the sun isn't going anywhere anytime soon, and it's a pretty special object as it is. But there are other objects that we don't normally talk about or realize even that they exist in our solar system. And hey, don't get me wrong, I know that the solar system is pretty big as it is, but we usually focus our eyes on either our neighbor planets or the sun or the moon, but there are more objects far away. As a matter of fact, we have millions of objects surrounding us, a cloud more specifically. The Oort cloud is the most distant region of our solar system, and it is believed to be a giant spherical shell surrounding the rest of the solar system, mainly composed of a space debris. It makes scientists suspect it to be the main source of most comets. Thought to be located somewhere between 2,000 astronomical units and to 5,000 astronomical units from the sun, taking into account that an astronomical unit is just the distance between the Earth and the sun. The Oort cloud is the home of the so-called long period comets that, as their name suggests, usually have extremely long orbital periods. And that's why we've been able to see them only once, most of them. Some of them were discovered by the amateur astronomer Terry Lovejoy, as a matter of fact. And now let's talk about this object, specifically what are asteroids. To make it easier to grasp, we can say that asteroids are just the small rocky objects that orbit the sun, not to be confused with comets though, whose main difference is the composition. Comets being mainly made up of ice, dust, and some rocky material, while asteroids are mostly made up of metals and rocky materials. Now, when do they become meteors and meteorites? Well, just to easily define them, a meteor is when one of these objects happens to enter and get burned up in Earth's atmosphere. Meanwhile, meteorites are when these objects actually end up surviving their passage through the atmosphere, and part of it ends up falling into the ground. Most of the meteorites end up being just rock, but a few of them actually end up being fully, or at least in part, made out of either nickel or iron. Quite interesting, isn't it? And now, is there something else out there though? Is there something else farther away, even farther than the Oort cloud? Well, the answer is absolutely. Our whole solar system is actually part of, we could say, kind of another system. In this case, we form part of the Milky Way, our galaxy. And the short explanation of what a galaxy is, including our Milky Way, well, it's just a huge collection of gas, dust, and mostly billions and billions of stars, each one with its own solar system. Well, it's kind of a solar system, but it's a different star, we could say. So imagine all the amazing planets we may be able to find out there. Life, perhaps? Who knows? Now, there are other objects as well that we can find out there, such as the remnants of stars, specifically what is left after a supernova, or as Arfa mentioned, is when a star explodes at the end of its life, sometimes creating a giant cloud of dust and gas that serves as the birthplace of new stars, and that's called a nebula. Now, when these stars are too massive, something else happens. When all of their mass gets compressed into a tiny, tiny space, its core ends up collapsing into itself, creating a black hole. Sounds scary, but more than that, black holes are fascinating. So fascinating that their force of gravity is so strong that not even light is able to get away from it. Do we have black holes in our galaxy? Oh yes, possibly millions of them. But again, no light means a really hard job to detect these sneaky, massive things for us astronomers. And well, everyone, you have been listening to the Alan I. Carswell Observatory's weekly Teletube broadcast, the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Dhyan, June, Maheen, Arfa, and myself, Matt. And well, make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer all of your questions. And all of our programs are free, but if you would like to make a donation, see our website at observatory.info.yorku.ca. And you can always connect with us on Twitter with the handle @York Observatory, and check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.